Good morning. I thought I'd do a quick video and update folks about my electric bikes. I know a lot of people that watch the channel watch it for various reasons, sometimes the radios, sometimes the e-bikes, so I thought I'd do a quick update on the e-bike. Right, this is it. This is a probably about a 40,000 mile e-bike. Can you believe that? You probably can. I bought this bike in order to do a conversion, which I'll pop up on the screen, about 12 years ago, where we built a gearbox to go inside the frame and a pancake flat Lemco motor to drive the bike. And although it was very powerful at the time, we didn't really have the batteries to support it. So at that time I was in touch with a guy called Mark Higgin from a company that sold motors for disability wheelchairs and things, and they at the time were trialling these motors, and they just literally launched, and the BMC geared motor, which you see in the back there. Now this motor is different to the direct drive motors which you see commonly sold cheaply, in that it's got a reduction gear in there. So the advantage of this motor over a standard direct drive hub motor is the fact that you get lots and lots of torque for a relatively small size, which means you can run also lower volts on your battery. You don't have to go up to the sort of 80 volt 100 volt mark to get the sort of torque that you need, and it also, you know, it gives you great climbing ability. So the downsides are in fact that there are things to wear in there, which is the clutch mechanism, which I'll throw up on the screen. The clutch mechanisms, you get, well, on this bike I got about 20,000 miles out of each one, and they're not that expensive to buy, about £60, and fairly easy to change. So if you're a little bit hands-on, if you're certainly a bike mechanic, it's not a problem at all. So this bike, it's done about 40,000 miles. I do on average about 4,000 miles a year, use it every day to go to work, and I've had it for about 11.5 years, the bike. So going on that, I know that it's done that kind of miles. Over that time it's had a new rim, because the brakes wore the rim out literally to nothing. So it's had a new rim. One thing I did do was, you see these brakes here, these are Maguras, because obviously they offer much better performance than V-brakes, but the other thing they do is the pads are very long wearing. I can get about a year out of a set of pads, whereas standard cheap V-brake pads only last about 2 weeks sometimes. So yeah, I put those on front and back. That's a major upgrade. So if you do have an e-bike and you haven't got the facility to run disc brakes, as I haven't on this old steel mountain bike, that is a really good upgrade. Magura throttle, a lot of the people use these cheap Chinese Hall effect throttles. If you're going to do it properly, get a Magura throttle. These are just absolutely amazing. Really good level of comfort, a good amount of twist. Never ever had any problems with them failing. I did make myself a cheap little battery meter there just to show the volts, which is quite useful. A kill switch, again, which is very useful, an on-off switch, particularly when there's kids stood around the bike if it's powered up. A horn, a very loud horn, a very loud hornet horn, although people still tend not to move out of the way for some reason. The brains of it, if you like, is this, the Crystalite controller. Now anyone that's been in the e-bike scene for any length of time, back in the day, this was the controller to have. It's hidden underneath this plastic here, but this is a 72 volt controller that was donated to me, and I uprated the FETs in it so to over 100 volt FETs with a lower on resistance to get better performance, and it has been, I haven't had to change it, I haven't had to touch it. It has honestly been bulletproof. Now with these BMC Mac motors and any of the geared motors, the safe and the sort of the best compromise, if you overvolt them too much, you'll blow the clutches and you'll blow the controllers, I found. But if you keep it to around 50 volts, that's the sweet spot for performance and reliability, okay? So if anyone is trying to match these combos and having problems with either the clutches going or stripping gears or the controllers blowing, we tend to find, because of the increased RPMs, these older Crystalite controllers and some of the cheaper controllers struggled with the switching speeds. and you could easily blow the controllers. It would fire them out of phase. It would fire the pulses to the motor out of phase. So I found the actual, occasionally you can run it up to 60 volts for brief periods, but I found 50 volts to be the absolute sweet spot. So if you want performance and reliability, do that. On a bike like this, a 26 incher, you could get about 30 mile an hour top speed. Depends on the gearing. There are different gearing arrangements with these, but with the standard BMC Mac type motor, it's about that sort of level. And I'm a heavy guy. I'm like 16 stone. It takes me up pretty much any hill with very moderate pedalling, or sometimes no pedalling required at all, obviously. Let's just show you the battery arrangement I've got. I went through about 2 beam racks, you know, the little top peak beam racks, and they snap at the actual bolt that goes through the back of the rack. So over time, so in the end I just put on their touring rack version. I've never had any problems since. So it's a really worn bag now, but that's where the battery sits in there. The battery's just in the other room, just finishing charging now. Because I am a heavy guy, look, this is how old and battered this thing is. Look, the seat post has snapped, the support there, and I kept breaking seat posts as well. So in the end I just left it. I just put a more comfy saddle on and left it. Yeah, so, but that's really useful, the battery meter under load. You can really get a good gauge of what power you got left. I don't run any BMSs, battery murdering systems, don't run anything like that. I just top and bottom balance the batteries every now and then, and keep an eye on the watts consumed. I'll show you the battery setup just in a sec. Right, inside the battery box are 2 of these. Look at the case that they sent you these in. Oh goodness, these are Hobby King graphene batteries. Look, they've got that lovely velvet bag they sent you. Very well packaged. You can almost make that into a battery box itself. Yeah, these are the graphene batteries. Occasionally appear on sale on Hobby King. I've got 2 of them in here. They were about £60 each at the time. They're 6S 10 amp per hour. So 2 in series gives me 50 volts at 10 amp hours, which is enough for most of the riding that I do. I temporarily put them in this ice cream tub, and of course, as it goes, I've just left them in there. They've been in there about a year. So, but what I have is, I have that, and we stick them in the top box bag. And then I also have this old other set. There's 2 6S 5 amp hour batteries in there, and they sit on top of these, and I strap them together with a strap in the back. And there's a parallel harness, with a very old one which I made here, which lets me parallel up 3 sets of batteries. So I could essentially just parallel these up to get 15 amp hours at 50 volts. And I've actually got an even older set of batteries which I could in theory put together, so I could actually get 25 amp hour at 50 volts if I wanted to go on a really long ride. But to be honest, these days 20-25 miles I've had enough riding that old thing. It's not much fun, so I don't really need the extra long range, but it's useful if you do. Just keeping an eye on these batteries. I mean, some of you will have seen these things. I just use cell loggers, occasionally stick them in, and you can also log the data from the batteries with those, and just your basic standard battery loggers. And then when the actual bike is on the go, I've got a really old beaten up watts up meter here. I use the watts up meter to keep a track of the obviously the amount of amp hours I've used from the battery, the watts, and see it, and just to double check to see if, make sure the battery hasn't dipped too low as well, because it gives you the minimum volts on there as well. So that's really the basic setup. I'll just quickly show you the charger that I'm using at the minute, and then I think we'll wrap this up. Right, this is the charging setup. I've got a Hobby King Quattro for 4x6, which will do 4 6S batteries in one go, and a little harness and loom made up for that. But what I mainly use is this, actually, which is a very, very nice little unit. This is the Radiolink CB86 Plus. Now this actually does the charging via the balance leads. It doesn't charge via the main leads. It does it via these balance leads. The very first version of this was fantastic. It would charge 2 batteries at the same time. But they changed the firmware now, so it only actually does one battery, and then it will move on to do the other one. But in practice I found this isn't really a problem. If you're in a rush it might be an issue, but it's never been a problem for me. At first I moaned to the supplier a little bit about that, but it does work really well, and it gets them very accurately balanced. So I tend to use this pretty much as my go-to charger. One modification I did do, when you're charging through these leads, you put in 2.5–3 amps through a very, very thin wire. So if you do get one of these, I recommend doing what I did, because I found on the really hot days, the plug-in connection at this end, the pin got blacked up. It was a bit too much current for it. So I actually did a modification and soldered these wires directly onto that board, and then hot glued them so they wouldn't move, so that it just removes that weak link. That was a bit of a weak link there, but the other ones seem to be man enough and survive. And you can plug in a total of four cells on this, and once it's done one, it'll just move on to the other, and then once it's done all of them, it'll then just balance them all. It's a very nice little charger, that. And I just run this off of a super cheap little Nevada power supply, nice compact little PSU. I know you want to hear what the horn sounds like. It's loud. The biggest problem with that, it sounds like birds chirping, and so if you do that when you're out and about, people, they don't tend to move out of the way. It's very strange. Look at how the recent hot weather absolutely destroyed the tyres. Absolutely ripping the tyres to bits. What was I going to say? There was one thing else I was going to say. Oh, these forks. Yeah, these forks have absolutely shot. The 40,000 miles has absolutely destroyed this set of forks. So really, I'm at the point now where, you know, what do I do? Do I get rid of the bike and put all the kit on another one, or repair this one? I don't know. I've got a lot of sentimental value built up in this, so we'll see anyway. As far as disconnecting the power, I've got Anderson connectors down here, 3 off there, off the phases, and a 5-pin DIN connector there, a standard audio type connector, and that's been absolutely fine. Not had any problems with that at all. I have had to replace the cable inside the motor that did actually wear and split, so I've actually put a new cable in there, which was a bit of a job. And also, I meant to say the motor's also had, over time, all of the hall sensors changed. One of the things with the cheap Chinese motors, they tend to use cheap hall sensors, and so over time each one had failed, and you know this, when they fail, the motor behaves very erratically and stalls. But you can pick up e-bike testers which you plug in, which will actually test your halls for you. So I've got one of those in the cupboard, but you can use a DVM if you're not sure. Just look for the pulses when you spin the wheel. This has got the freewheel mechanism in, so there's no option to do regen with these motors because it freewheels. It's got the freewheeling clutch. So I'll just show you a quick video of the actual clutch mechanism. This is the clutch that's inside the motor. These are the same type of clutches fitted in the BMC motors or the Mac motors. They're exactly the same. This has got some composite plastic gears on it. It's supposed to be harder wearing. This is a new one I've got in just in case. There's a one-way bearing fitted in there, and a keyway which fits on the motor shaft, and this bit spins independently inside there of the actual planetary gear, which enables you to pedal without driving the motor around and the motor to freewheel. So it's a very efficient way of doing it. Like I said to you earlier, if you put too much power on these, though, if you run too much power, you will actually prematurely wear the splines inside that one-way mechanism, the sort of pawl arrangement that's in there. But if you keep it down to 50 volts, 30 amps, 35 amps, you'll not have any problems. Like I say, I did over 20,000 miles of really hard use. I take that bike at the moment, it's really dusty because I take it off road, I take it everywhere, and you know, I think that's pretty good going, and they're not that hard to change. Just a normal, like a crank puller type arrangement will pull the clutch mechanism off, and it's the sort of thing, if you couldn't do it yourself, your local bike shop would do. But I just thought I would just update folks, just to show them you know, kind of, you know, how this has been, because some people may have seen some of my older videos of this bike and wondered exactly what it was up to, and that's what it's still up to. It's still going. 40,000 miles. I think that's pretty impressive anyway. Alright, I'm going to leave it now. If you have been, thank you ever so much for watching. Keep an eye on the channel for some more e-biking videos and some more radio videos. I'm feverishly working away on new content all the time to keep you guys happy. I hope you've enjoyed this one. We'll catch you on the next one. Cheers.
And you know the bike is dangerous?
Yes.
Okay.
Oh my god!
You were not joking. Careful, careful with the throttle, careful with the throttle.
Careful! You okay?